Okay, so a quick video going through the transition phases of a star. Okay, so we're not going to talk about every single stage of the star, just why it moves from one stage to the next, and we'll look at the most common ones. So what happens, why does a main sequence star move from being on the main sequence to being a red giant or a red supergiant? Well, to start with, we get this, a main sequence, and it can be stable there for millions and millions of years. So what we get is gravitational force is equal to the thermal pressure. Okay, so we get equilibrium, and during that stage, hydrogen is being fused into helium. Well, what happens? This transition stage starts when it starts to run out of hydrogen. So what we first of all get is less fusion, therefore less thermal pressure, therefore gravity wins. So gravity starts to shrink this star down. Its colour changes as well because its temperature drops. Gravity starts to win, and as it gets smaller, gravity wins even more because the radius, remember, is getting less, and we know that the force of gravity is inversely proportional to the square of the radius of the object. So that's the first thing. So as this star is collapsing, falling in on itself, what happens is we get more fusion. We start getting helium fusing into lithium and larger elements. So the star starts to heat up and it starts to grow. So now it's on the right hand side there, temperature is now bigger than gravity, so it's going to grow. So it swells, and it swells out past the original size, out to a new equilibrium. So now the temperature is much lower, but because the star is much larger, we finally get equilibrium again, because the radius now is much, much greater, therefore the force of gravity is much less. We get a new equilibrium that's much colder, but the star is much, much bigger. So the gravitational force of attraction on the surface is much lower than it was. Okay, so that's what we get. We kind of get this shrinks down and then it bulges back out to a new, larger, cooler equilibrium. Okay, red giant or white dwarf or planetary nebula. We start off with our stable red giant now, so we get fusion of helium into the larger elements, and we can see here gravity is small, temperature is low, but again it's an equilibrium. Well, what happens? First of all, it starts to run out of helium, cools and shrinks. This time though, the gravity is so low that the outer layers don't move, they stay where they are. So the inner layers collapse in on themselves towards the core, but the outer layers don't, and the outer layers just drift away then as planetary nebula. And at the centre, we're left with the core of the red giant, which forms the white dwarf, and eventually it'll cool into a brown dwarf, black dwarf. So that's not particularly exciting, that one, but that's how it happens. Next one, red supergiant to a neutron star or a black hole via a supernova. Now this one's a bit more interesting. We start off now with our large supergiant. Okay, so we get, again, the gravitational force and temperature are balanced initially as the fusion of helium into bigger elements. Transition stage one. First of all, what happens is we start to run out of helium. So it cools and shrinks. Gravity is much bigger now, so it's able to pull the outer layers in. And this whole star starts to collapse in on itself and accelerates. All the particles are accelerating, gaining kinetic energy as they head towards each other. What happens then is we get a huge increase in fusion reactions. So some of the elements being fused are larger now than iron. And we get a massive, rapid increase in temperature. And as we get that, in the same way that earlier when our red giant was formed, we get expansion, but this time the expansion is so rapid and so violent, and the thermal pressure is so great that gravity is unable to hold on to all those bits, and we get this huge flash of a supernova. Okay, so the outside layers just disappear off into the universe. And what we're left with then is the neutron star or the black hole. So the core of our super red giant is a very, very high density, small but massive a lump of material left in our universe. Okay, so that's how we move from one thing to the next. Hope that helps.